Hi guys, we are going to do a video today and I want to apologize because I meant to give you the new packet yesterday, and I completely forgot. So we are actually in notes packet part 2, okay? So what I want you to do is to take notes. Luckily there's really no graphing, so you can take your notes directly in a notebook, okay? Hopefully some of you have time. I'm going to make an announcement tomorrow and you can pick up those note packets in the morning when you're at school. If not, do not worry. This video is hopefully going to be short and we can do it right in your notebooks. So bear with me here. We are going to start on page 64. And this again says packet 1 because I have it all as 1, but it's actually in your packet 2. Okay, so we're going to say part 2. Okay, we are talking about lesson 4.4 in the textbook, and that is finding slopes and rate of change. Okay, so a slope, I'm going to give you 2 definitions, okay? First is going to be the ratio of the vertical change. And know that when I put change, I always put a little triangle. That's how you define change in math, which is the rise, okay? The ratio of the vertical change to the horizontal change, okay? And that's what we call the run. Okay, and my second definition is just the measure of steepness of a line. Okay, so the measure of steepness of a line, okay? Now if we go over to rate of change, the rate of change I'm going to say is situational, okay? It depends on what we're talking about, and it usually comes into play when we're talking about word problems, okay? So it really is the slope, but when we're talking about word problems, we don't call it slope, we call it the rate of change. And it's how one quantity changes in relation, we're going to use a triangle again, changes in relation to another quantity. Okay? You might have things like miles per hour, okay, MPH. Okay, that would be a rate of change, miles per hour. Okay, that's an example. Okay, moving right along, we're going to go down to the bottom. This is the only part where we're going to do a little bit of graphing, but it's pretty simple. Okay, when we talk about a positive slope, again, we read lines from left to right, okay? We always read lines from left to right. So I'm not going to, let's see. Sure, we'll insert a line. So this would be something that would be from left to right, and it would be a positive slope, okay? It rises from left to right. Okay, on the other hand, if we have a negative slope, okay, it's something like this, right? And if you read it from left to right, it falls. Okay, falls from left to right. Okay, and that's the difference. And again, make sure you're always reading those graphs from left to right. Now, if we talk about a slope of 0, and again, it's not none. You don't say it has a slope of none. It has a slope of 0. We're talking about our hoi line, right, which is a horizontal line. Okay, so if we draw that in, we have something like this, right? A horizontal line. We put our arrows. That's a slope of 0. If we have an undefined slope, okay, we are going to have, let's see if I can get this here, a vertical line, okay? And that is a slope that we call undefined. And like I said today in class, some people like to remember it by, if you're skiing and you're skiing on a flat surface, it's a horizontal line, it is 0 fun, okay? If you're skiing straight up and down a hill, which is a vertical, that's an undefined amount of fun. That's kind of how I teach it sometimes for people who are struggling to remember horizontal slopes versus vertical slopes, okay? So make sure we have our line on there, and we are moving on to page 65, okay? And now we're going to talk about ways to calculate slope. Okay, so way 1, counting the space on a graphed line. where the slope, or the m, remember slope is m, and we're going to talk about it as rise over run, or you can say vertical change over horizontal change. Okay. Calculate the slopes of the following graphs. Remember, you always start with the leftmost point. It's easier math. You're going to count your vertical change, or your up and down, okay? And then you're going to count your horizontal change. Okay, so if we move down to this first one, we're going to start with our leftmost point, which is right here. We're going to count our vertical up or down, so we're going up 1, 2, 3, 4. Okay, so we have a rise of 4, and we're going up, so we're positive, and we run to the right 2, and that's also positive. So my slope is 4 over 2, or simplified, a slope of 2. Okay? Here on this next one, let's see, our leftmost point is here. We're going to rise, but we rise down, so I hope you recognize that that is a down 1, right? Which is going to be a negative 1. And we go to the right, 1, 2, 3, 4, a positive 4, okay? So that's a slope of negative 1 over 4. Again, when we rise, we can rise up or down. I know that's weird, but that's how we do it when slopes. And we went down 1, so that's negative. We went to the right 4, which is positive. And my last one here, let's see, we are right here at my leftmost point. We're going to go up 1, 2, 3, and we're going to go to the right 2. So we have a slope of 3/2. Okay. Next page, we're in the home stretch here. Calculating slopes. Okay, so we talked about on the previous page how we calculate slopes on a graph by counting. Now we're going to talk about calculating slopes using a formula. And you should remember this from last year with Mr. Robert. We have our slope formula, which is y2 minus y1 over x2 minus x1. Okay, now, when I'm doing this, I know some of you you've got this. But I think at first it's going to be really important that we label our x's and our y's. So we have two ordered pairs here. This is my x1, this is my y1, this is my x2, this is my y2. And then it's as easy as plugging it into the formula, right? We've got 8 minus 5 over 11 minus 2, which is going to simplify to what? 3/9. And you need to simplify, so that's going to be a slope of 1/3. Okay? Let's skip to letter C. Okay? So again, I label them x1, y1, x2, y2. We got a slope of negative 1 minus 3 over 4 minus a negative 2. Negative 1 minus 3 is negative 4. 4 minus a negative, that's going to become a positive. So we've got a 6. Simplify that down to negative 2/3. Okay? Now some special cases here below. D, E, and F. I want to talk about D and E. Those are the two we're going to do today. Again, we label X, oopsie, got to get my pen going here. X1, Y1, X2, Y2. Now, when we do that, you're going to see 2 minus 2 over 2 minus a negative 5. So we get 0 over 7. Whenever you divide 0 by anything, you get 0. So the slope is 0, okay? It's not none. You're not going to say it's a slope of none, okay? And I hope you recognize, because of our Hoyle-Vux lines, horizontal, that is a horizontal line, okay? On the other hand, look what happens on this second problem in letter E. We label x1, y1, x2, y2. We do our slope, negative 4 minus 2 over 3 minus 3, and look what happens. You get a 0 in the denominator. I hope you remember that you can never, ever, ever have a 0 in the denominator. What that means when you get a 0 in the denominator is that your slope is undefined, okay? Which, again, an undefined amount of fun, so you're skiing up and down, so you have a vertical line, okay? Next page. We're on 67. Let's see here. Oh, you know what? This is just your Hoy-and-Vux lines. Why don't you complete this on your own? Complete for homework, okay? You should remember how to do that. And I will be checking that in tomorrow. Okay, if we look at our practice, I want to look at number 1 here. We have, in 2012, a public library has 16,000 books on its shelves. In 2016, the library has 19,000 books. Find the average rate of change in the number of books per year. Okay, again, word problem, so you're going to see that term rate of change. We're just looking for our slope. Okay, and what I always tell students when we're talking about something, when we're talking about years, your starting year is your year 0, okay? So our starting year here is 2012. You're going to let 2012 equal year 0, okay? So then I actually write out my ordered pairs. 2012, which is year 0, we had 16,000 books. In year 2016, which 2012 to 2016 is a 4-year change, so 4 years, and my Y value is going to be 19,000 books. Okay, and now you can easily calculate your rate of change. I still label as slope, 19,000 minus 16,000 over 4 minus 0 is going to give me 3,000 over 4, which, what is that, 750? Okay, so here we're going to say M equals 750 books per year. Okay, not so bad. Number 2 is very similar. I just want you to recognize that your year 2000, see, there's 600 births in 2016. In 2014, there were 550 births. Find the average rate of change. So 2014 is year 0, okay? And 2016 would be 2 years later. So you got 2 comma 600, and you've got 0 comma 550, okay? And you can do that one on your own. Okay, last page where I want to spend a little bit more time on. I hope you saw this last year, but I don't know where you guys left off. So I want to make sure that we're crystal clear on this, okay? Again, slope. We know it's y2 minus y1 over x2 minus x1, okay? What's different about these problems? These are called missing coordinate problems. So I give you a coordinate, I give you another one that's missing one, and I actually give you the slope. So what we're going to do is we're going to write the formula. M equals what? Y2 minus y1 over x2 minus x1. Okay, I'm going to label them. We've got our x1, y1, x2, y2, and then I'm going to plug them in. Okay, y2 is -2 minus, oh, we don't know what y1 is. It's just labeled as y, so I'm going to plug in my y. Over x2 minus x1, x2 is -9, minus, let's see, what is my x1? It looks like it's a -3, right? So we'll have a -3. And we actually know the slope. It's 1. Okay, how do I solve this problem? Well, here I've got -9 minus a -3. So that becomes what? -6. Okay, so I'm going to just erase that for now. We're going to have -2 minus y over -6 equals 1. Now, some of you just recognize that you're going to use cross products. If not, do a 1 over 1. Okay? And we're going to cross multiply. 1 times -6 is -6. 1 times anything is that same thing, so -2 minus y. We are going to add 2 to both sides. We get -4 equals negative y. Oopsie, sorry about that. And you're going to divide by -1. And you get y equals 4. So what that means is that your missing coordinate here is -4. Or sorry, is +4. If you were to plug that back in, it would give you a slope of 1. Okay, let's try one more here. And I think that'll be enough then for today. If we do, let me just change colors here so we can get some variety. I'm going to label x1, y1, x2, y2. Okay, we've got y2 minus y1. That's going to be 2 minus y. Over 3 minus 9 equals my slope, which is 2/3. Okay? We know 3 minus 9 is -6. Let's just change that so we can see it. So -6. And now I'm going to do my cross products. Multiply this way. Multiply this way. 2 times -6 equals 3 times 2 minus y. Okay, I get -12 equals 6 minus 3y. I will subtract. Now it's simple multi-step equations. We've got -18 equals -3y. We're going to divide. Sorry, I'm changing my pen here. We're going to divide by -3. And we get y equals a +6. Okay, I think that is plenty for today. Go ahead and practice those extras that I haven't done if you'd like. And you can go ahead and start on your